Hola. Buenos días.
Good morning. Thank you for joining us this morning to the GeneXus language evolution presentation. Let me start with a programming exercise in JavaScript. You don't need to know much about JavaScript, but these brackets are an upgrade, and the curved ones are an object. What happens when you add one to the other? I'm not an expert in JavaScript, but using programming techniques, one I did object mass array equals an object, could be, or an object inside array, or whatever combination, a group of objects.
Bien, digo, todo es un objeto.
It's all an object, objects. JavaScript is not, well, quite an object, but it's justifiable. Now, array plus an object, the other way around. If 1 plus 2 is 3, 0, well, this is 0. I didn't do this one, but we have, what's an object plus an object in JavaScript? Maybe 0, maybe object. It should be object. I was almost sure, but not both precisely. This is what appears on the console. But you'll probably think that I'm laughing at JavaScript because JavaScript is one of the most popular languages. No, I'm not poking fun at it. I'm just reflecting on this. It does not follow the guidelines of what you might find in a book that refers to creating language. However, this language was very successful in many parts where other languages following the rules, doing everything as it should be done, or as we think, or as many people think should be done. Java, at least in all that has to do with the Java platform, it was not successful on the web, but JavaScript was. Why? Because JavaScript has very good parts. It was created for something. It's dynamic, it's very speedy on the web, and it was created for that. And they're very good at that. It's the best language we've ever found. So, Crockford wrote a book about the good things about JavaScript. And apart from the ones I showed you, there are many, many more. And there are also inconsistencies. Things that could be taken lightly. But the JavaScript community doesn't care about that. The important things are the good parts. Why was that language created? Where should it be good? So if we do something special, what I wanted to show in this presentation, you know that in our TED, being motivated by Nicolas, one of the things we focused on was to realize what we are good at. What are the good parts of the GeneXus language? Which things we did well and which things we have inherited and were accidental complexities. So when we talk about language evolution, we start thinking about why is it that I don't have multi-threading or section managers or many things that were asked this morning and many others that were not asked. Sometimes I myself say, well, we should have this. Why not have a dictionary, for example? But in general, you end up finding that many of those things are necessary. But when you try to include them in GeneXus, you say, well, is this really necessary? There are things that are very complicated for what we are trying to create. This is a business application. We need to focus on the business. If you have a sections manager, that adds complexity. And we don't want that to happen. We don't want to incorporate that. We need to think about why we need it more carefully. So when you think about language evolution, you start adding up things. A short time ago, Nicolas told us, instead of adding, we need to subtract. We need to remove. We need to reduce the use of many things. That is why we went to what is basic. What are the good things about GeneXus? Well, the things that were there from the very beginning. Brogan talks about use of use. We all know about that as a transaction. And this is what GeneXus is good at. In the GeneXus community, we never talk about data binding. What is data binding? Maybe many of you know what that is because of your training, but this is not something that we're worried about when we put attributes on the screen that are part of a transaction. We don't know how it came here, how to link with a control. No, we are. That's not a concern. It's oriented to data. So if I have a grid that brings data, if I do a for each, I name things and they come. There are joins, of course, in some cases, but we're not worried about SQL under it. At first, in the initial instances, and this is something we can improve, we always use an abstract language. We are not concerned about many things around the transactions. When we start with other constructions like SDTs, word service, we start generating complexities. Why is it that I don't have a filter or a for each or an SDT and many of the things we have? We start saying, well, if we use transactions, many of the scenarios will be simplified because one procedure that adds a lot of value from a stock procedure, what should be done today, if that's behind a transaction, it brings it, and then the transaction has a data binding, and I can put it on any screen, or I can do a for each on that, or I can select, or a projection. I can do the algebra relative to that, which is much more powerful than the services I can create today. So around transactions, we started thinking about these things, and we saw many scenarios. Some are very simple. In fact, the way to capture the attention was to knock on the door and say, transaction, come in, and then we start talking about something, and then we branched off. But that was a way to draw the attention of Nicolas. And one of the first things we worked on was data initialization. Sebastián Gomez was tweeting something. He said, our systems are so good as the defaults through which we deliver them. We're going to apply many things in GeneXus, but the systems of our own customers see very frequently that they do data initialization. Sometimes they have initialization of values which are default values. Or we know some values, but we want the users to enter other values. Or we know all values. And those things today are very simple. But they take time. We need to write a procedure that calls for one thing, then loads another. And these are things that could come and be already included in the knowledge base. And so we simply distribute the defaults. So let's see how we start thinking about it. And last year, Gustavo Brown talked about this, but now most of these things have been implemented. Nicolas, and we want that by December. We will always want more. We want more time, but he wants for December to have as soon as possible. All these things that have been done already, or most of them have been done already, we want you to give us your feedback, and we want to find more scenarios. I won't be able to see all the scenarios we've been working on, but the first one is that some default values are here. So if we have a transaction that is countries, and we want to add some data, this will be under country. This is a data provider by default, and we can add a few values. I will have a feature that will ask me, when do you want to enter those values? Well, at the time of creation. And these are default data. I just put 2 or 3 countries, but eventually we could have even the names or more cities, or I want to delete one country. That is possible. So I will say that the update policy needs to be updatable so that it can be modified. It's like what you always do. You have a table, you can modify the table. And what does GeneXus do with this? When I give it this click database, I don't know if you can read it. It says, run initialization program for table country. That's saved calling the pro. At the time of creation and reorganization, we run this procedure, and this is automatically done. And that would be the first point. The second case, I have a few known values like currency. I put peso or dollar, and I don't want these 2 values to change. They are correct, and in my design I decided these are the 2 values. Of course, there are other currencies. So the only difference with the previous case is that at the creation time the execute time is the creation time, but it is extensible. The update policy would be extensible. GeneXus will not allow me to modify these 2 values, but it will allow me to extend them. The frequently asked questions. What about transactions dependencies? We need to worry about one of these things when you program manually. That's the order of things. I cannot put the city before the country, for example. What about initialization? Can initialization be used programmatically? What happens with all these dependencies of the transaction? Well, GeneXus will take care of that. GeneXus will do it. And in the second question, yes, I can call it programmatically, and I will have a name for that method. And what this will do is an upsert. It will not do an insert. The first case is an insert. If it exists, it's updated. If not, this simply insert. Around the upsert, we will be talking about this in different collections of components and business components. There are many, many other things around this to help in this scenario. The other case, the 4 values known, and I could say the creation time is the execution time, and the update policy is read-only. We could think that this is created at the creation time. It will generate a table. It will generate other things so that I cannot update it. But in fact, in this case, it's clear that there will be no other modifications. So the execution time, we say, is more dynamic. It can be in the memory. It can be loaded at the time we're going to use it, and then we don't need to go to the table anymore. When we say that the execution time is dynamic, GeneXus is generating a view of the SQL. Instead of creating a table and then loading the table, we create this view. It's read-only by definition. It's a way in which we imagine something if we were to do it manually. We create the view. This is an automatic view created by GeneXus. In this case, it's very simple. We can even read it. But if at the time of when we chose dynamic, we meant to exploit something else GeneXus is very good at. It's very good to move from one abstract model, which is a transaction. And some people who do not belong to the GeneXus community believe that a transaction is like a table, and they relate it to the relational model, and that's a mistake. That's a mistake because they are not a member of the community. But the transaction is an abstract model. We don't necessarily have to have a relation on the data source, but moving from transactions to relational data source, that's what GeneXus is very good at, and we want to add more power to this possibility. So in that view, we had fixed values, which seem to be very simple. But what if that data provider becomes more complex and adds more elaborate things? In that case, we start finding that there are many cases that GeneXus today solves by reprogramming, and we are very enthusiastic about that. But data initiation is more important. What happens when we defined it as dynamic? Nicolas called it first intentional transactions, then it went to marketing and they said, no, that's dynamic transaction. And that's why we call them dynamic transactions. These have an associated data provider. It could be a little bit more complex, but we start seeing things like this. If I have a case where the table is a client's table, and this table has an attribute, whether the customer is active or not, in many places, I will see in my programming that if I need to give them a discount, I want an active customer. If I want a certain kind of operation, I will choose an active customer. And that becomes an element in my business, the active customer. Today, I'm taking that programming through different scenarios. I could have a data selection, but the active customers are a component of my business. Why not put them as part of a transaction? If they are part of the transaction, the data provided associated, instead of loading fixed data, will say, I will filter to see whether the customer is active or not. Now, GeneXus generates a view using a filter. And we start imagining different cases. I can have the data binding, the associations, and all that automatically on the active customers. For example, I will write less in many cases. I don't have to include the grid and say this is an active customer. I don't have to have a for each. I do for each if I just want to get the names of the active customers. I name it and it comes. These are views. And I could say, what happens if I have discount coupons? I'm going to give them only to those who paid to the active customers. I'll give them discount or promotional coupons. So I write here coupon, and I put active customer ID and his name. What do you expect if I do something on that table? This will generate a table for the coupon. What happens if I insert a coupon for a customer who's not active or does not exist? Well, you may say that's obvious. I expect that they will bring an integrity error. Now, that seems obvious with a table, but in the SQL, we don't have that integrity between tables and views. This is simply to say that Brown implemented many interesting things here. GeneXus, when it finds these integrity relations between a table and a view, it will generate triggers. So when you want to insert, update, or delete on that table of coupons, it not only generates a table, but it generates triggers to check against a view and see whether the customer is active or not. And they use triggers for that. And they do this by generating a code as well. If you have another coupon, you cannot give a coupon to someone who's not active. So we are trying to use the full power of SQL, which so far in many cases we had not been tapping on. So referential integrity is fun. It's quite fun. We need to work a little bit more on it. We have already implemented many good things. We can also do aggregation. For example, in the case of monthly sales. And this eventually could be a dynamic query, but many times there are business issues that will be like this, and I can have them materialized as transactions. And GeneXus can also take this up and generate a view for it, and you can do for each for this. So there are many queries that I will be able to deal with automatically. And this, of course, uses all the query technology behind it. And many of the questions you raised this morning, if you don't want this to be dynamic, you can do it in such a way. And the query object will be like a counterpart of a transaction. Now let's see another case. There are many cases, but unfortunately I cannot cover them all. But the classic people and organizations, this is basically the kind of operation in some systems. This is a pattern, a business pattern that says there are operations. For example, a movement or a purchase that can be done by a person or by an organization. They share a few characteristics in common. I did this very simply here with a name. And this in general, well, these things today, many times I can solve with subtypes. But then I have to do procedures when I insert in one place to insert in another. And the grid is quite complex to program. It can be done, but it's not easy, in my opinion. And I have person, organization as always, and the pattern says that we need to have a transaction, a party transaction, which brings things together. And I could write in a data provider, I could load party, either the person or the organizations. These are, in SQL, this is a union of two things. GeneXus could do it, but not in this way. So this creates a view which unites these two things. And it's great fun because we can check integrity when I put document or party ID. It will check to see if it's an organization, a person, or what it is. So the for each today, if you like, maps the SQL directly. And this is what we are focusing on. We are trying to convert this. GeneXus is very good at doing this. Fortunately, SQL, many people discovered that SQL is the best way to do interfaces with data sources. Now, one of the most common things is that we have more and more APIs that I have to access. There are many things that come as services. So why not hide this behind a transaction in some cases? For example, in business services, when I'm given a service that includes a list of customers, and if I get a list of customers, I could do something like this. I have the customers, I write the data provider that will use the word service, and this is the access. I access the customers, and every time that I do a for each on customers, it goes behind to a hidden service. When you show this, you may react saying, well, this is not efficient, because the service gives me the customers, but then I have another that gives me the keys, and if I filter by name, I'm using the get by name of the customers. I'm not using this. You're going to give me all the customers, but if it's a for each where the customer name is this, you'll bring all the customers here. That's too much. Then you need to filter the names, and no, that doesn't work. So many times, why do we do this? Because from the for each, I have to do a mapping with a projection to services. And in the data providers, then, which are associated to transactions, we will add a match sentence. If you have get customer by country or get customer by ID, you can do a matching sentences, a match where customer ID, that's a way of writing it. I will call this service. If they filter through ID, I choose this service. If they filter by name, I choose the other, because there's no other service. But GeneXus, in this case, after writing this once, when I do for each, customer name where customer name equals Pedrito, I will have a customer ID, and we will use this matching that I have first, and it's going to be more efficient. Notice that if I wanted to page this, I could call other services, but we hide one API for services behind the transaction, and then I use the transaction with all its with all the characteristics of the for each or the data binding. They can appear on the screen without having to ask where things come from. So I hid the complexity of accessing services. Now, this is one way. I have many services, but today somebody said that he needed to have access to different storing systems. And up to 2010, we thought that relational databases do not scale up, are not good to be used, but then it's not that they are not useful, they are a complement rather. And SQL didn't serve a purpose in that scenario. But today, fortunately, we are realizing that the property of scaling up, you can scale up today in SQL, and companies like Google, Facebook, and Twitter, and really doing the SQL, which is MySQL, and it's a fork of MySQL, and they will take things from SQL. And Google has its own business too. Google is an advertising company, as Eliak said, and they migrate from Bigtable to F1. The storage is not always relational, but it doesn't matter because the interface is SQL, and GeneXus is very good in using SQL, which is good news for us. SAP HANA by columns or rows uses SQL. And they use the full power of SQL. Some are more powerful than others, but in fact, we are realizing and we are convinced that the power to relate is unequaled. How did we realize this? Because people realized that they needed joins before going beyond those cases where the documental databases are used. The interface that is SQL, regardless of the storage, is very good. And as I said before, GeneXus is very good to do that. This is good news, and I could also add that all technologies left a footprint in the systems, and I'm going to arrive there and I will find a non-relational database, but the SQL will be there. Now, how do I access this? In a similar way, but at a higher level. When we plan this, we say that the transactions will move into multiple data sources and that the mapping of the data sources will be extensible. We will be doing some like DO-data. We don't have to program the query matches, but I will simply have the for each with an abstract branching off, and I will be able to know what to do, and I will give this to the provider. And if OData can do that, it will be mapped into OData. Then I will go to MongoDB provider, and if somebody needs that, we'll do that. We'll have to check that, but we can give him this and try to map it. So all will be approached as a transaction, and we will be able to generate data sources, and we will start programming with the customers. And if the table, once we want to implement it, is in MongoDB or MariaDB or SQL Server or behind a service, it doesn't matter. It won't matter. In some cases, the specifier will give me warnings if the joins are gigantic, and I have to manage 3 million registries, and from two different data sources, and there's nothing to join these two things that may cause problems. We don't want to hide reality. If reality says this will take time, we will try to reveal that it will take time. If that's not a problem, GeneXus will try to not to give you warnings. So transactions are the interfaces. And why not eventually do certain things that are today approaching objects or geared to objects? Why not do these same things? More table-oriented or more transaction-oriented. I have just coined the word. We are the only people who use the use-of-use invention by Nicolas and Breogán. Why not transaction-oriented for each process, for each permits, for each? We are seeing these things. Why not the modules? The modules as transactions. Many of the things that I will present are transactions. Many procedures will be hidden as transactions, and the caching can be done from there. Everything is here available. So I understand when you say, let's talk about the evolution of language, let's see how much to be added. But we are doing the opposite. We want to replace things and we want to simplify at this point. We have talked about many things. Why not dictionaries? Why don't you have a dictionary? But dictionary is a transaction with a key that is not well defined, that is in a place. There are many things like that. We are thinking about it. There are many, many ideas, and we need to think about them. Nicolas once sent me papers by a humble boy called Top Man, and he was Top Mind. I don't know his name because he has this nickname, but it's very controversial, object versus table-oriented, and there are many battles to be waged, and this Top Mind guy was victor in many of these battles, and we are stealing some ideas or from him, thinking about those ideas. We start thinking about what a dictionary is, what is a queue in programming, what is a stack, and many of the things are very complex, and we can solve them in a very easy way by using a table. So the good part about GeneXus, transactions, and many old constructions. Old but good. Much complexity included over the years. Brogan told me a short time ago the components are difficult to use. Users of GeneXus many times think this is natural. You do load, you do this, you do that, but why not do this, which is more simple? I'm late, but I'm about to sum up. So things around for each, around new. So instead of saying, okay, let's do this, let's look at this object-oriented things, we'll change a little bit. We'll look at some basic things, we'll improve some basic things. For example, when duplicate update, instead of doing a for each and repeat certain procedures. There are many, many things that we need to talk about, and we have talked about them these days. Willie was sharing some ideas, and new ideas are coming up. So we are very interested in listening to you. And if you want to capture the attention of Nicolas Brogan, say transactions, transactions, that's a word, and you will draw his attention, and then you start talking about other things, but this is a good way to start. And finally, I would like to mention something that Nicolas presented in some of his presentations. I don't know when it was, I cannot remember the date, I don't know what we were talking about, but he's talked about a concept called leapfrogging. It means that when you're late or in the most developed countries in telephony were the African countries, not because they arrived late into the market. They didn't have the infrastructure that other countries had developed, but most of the bad things that we inherit because we were very much ahead of our times, some we did not inherit, of course, these things they avoided. They didn't experience the accidental complexities of technology. They did not experience, so it was leapfrogging. They jumped from scratch to a more advanced period, and they have the best prepaid cellular phone systems. So the GeneXus community is going to experience something similar. If you are fortunate enough to avoid some of the complexities of language, and you are the ones who know about 4-each and you like that, and you have the transactions, you will be able to do some leapfrogging in the GeneXus language as well. Thank you.